Section 2.5, quadratic equations. In this section, you're going to learn how to solve quadratic equation by factoring. You're going to learn how to solve quadratic equations by the square root property. You're going to learn how to solve quadratic equations by completing the square. You're going to learn how to solve quadratic equations by using the quadratic formula. And then finally, we're going to discuss complex solutions. Solving quadratic equations by factoring. An equation containing a second degree polynomial is usually called a quadratic equation. For example, equations such as 2x squared plus 3x minus 1 equals 0. Notice how we have a second degree term. So this is a second degree polynomial, and x squared minus 4 equals 0 are both quadratic equations. Again, this is a second degree polynomial as well. If a quadratic equation can be factored, it is written as a product of linear terms, actually linear factors. Solving by factoring depends on the zero product property, which states that if a times b equals 0, then either a equals to 0 or b equals to 0, where a and b are real numbers or algebraic expressions. In simple words, the product of two numbers or two expressions equals to 0 if the product of two numbers or two expressions equal to 0, then one of the numbers or one of the expressions must be 0, because 0 multiplied by anything equals to 0. So if I say a times b equals to 0, you should be assuming that either a is 0 or b is 0, because multiplication by 0 must result in a 0. Factoring and solving quadratic with leading coefficient of 1, as you saw in unit number 0 in the review, we discussed factoring quadratic expressions when the leading coefficient is 1. In this case, because we're using the factoring method to solve quadratic equations, you have to notice that the right-hand side, which is, I'm going to highlight pink, didn't mean to highlight the whole thing. The right-hand side must be 0, just because we're using the factoring method, which relies on the product, zero product property. So the right-hand side in this case must be 0. If we're using other methods, for example, if using the square root property, you don't have to have the right-hand side 0. In fact, you should have a number on the right-hand side, and then x squared should remain on the left-hand side. So to factor the left-hand side, this is left-hand side, we're going to put the places to hold the two factors, linear factors, which are binomials in this case. X squared factors into x and x. Now, I noticed that the sign of the last term is positive, which means both of the numbers that I have to think about, both are either positive or negative. In this case, both are positive because the middle sign is positive. But when the constant term sign is positive, you should understand that both numbers that you think about, that their product is C, which is in this case positive 6, and they add up to the middle term, which is in this case positive 5. When the last term sign is positive, it is understood that both numbers have the same sign, and that same sign is the sign of the middle term. So both of them have positive, positive. So I'm thinking about two numbers. Their product is 6, and they add up to positive 5. Those two numbers are 2 and 3. Now we're going to use the zero product property. If two quantities are multiplied and their product is equal to 0, then either the first one is equal to 0 or the second one is equal to 0. So we make each factor equal to 0 and then solve. These are linear, so I can solve by subtracting 2 and 2 for the first one. I will end up with x equals 0 minus 2 is negative 2, so that is one of the solutions. Or I solve the other one. and I get minus 3 minus 3. So I have x equals negative 3, and that is the second solution. So our solutions are negative 2 and negative 3. The second one, number B, x squared minus x minus 56. Again, we have the right-hand side 0, so we're going to factor the left-hand side. We're going to put the two binomials or linear factors. X squared factors into x and x. The sign of the last term is negative, which means we're going to have different signs. The middle term is negative, which means the number that is bigger is going to take the negative sign. So here are the factors of 56. So I'm thinking about two numbers. Their product is negative 56, or you can just think about the 56 by itself. So I have 8 and 7. These are the factors. And I know that the bigger number, which is in my case the 8, is going to go in the negative, is going to be the negative number. So negative 8. So it's going to be negative 8 and positive 7, like that. So you don't have to think about the signs if you are doing it this method. But observing the signs can help you with the choices. But you don't have to. You don't have to do it that way. You could basically say two numbers, their product is negative 56 and their sum is negative 1. And you can figure out that they have different signs. And by knowing the factors of 56, you will be able to figure out the choices, just like I did here. So you could have just said, well, I have two options, either negative 8 and 7 or negative 7 and 8. And you know immediately that the second option doesn't work because that does not add up to negative 1. So you can try that as well. Now we're going to set each factor equals to 0. And we're going to solve. Minus 7, both sides. We get x equals negative 7. That is one of the solutions. The second solution, we're going to set x minus 8 equals to 0. So we're going to add 8 to both sides of the equation to solve that linear equation. We end up with x equals positive 8. So our solutions are x is equal to negative 7, x is equal to 8. Number C, x squared plus 4x plus 8 equals to 0. We're going to put the factors, make that equal to 0. We're thinking about, so x and x, both numbers are having the same sign and both of them are positive if they exist. Now, all of the factors of 8 are 8 and 1. So I know that both numbers have to be positive just by observation. And we have 2 and 4. Those are the factors. None of these work. The first one doesn't work because if you add 8 plus 1, the answer is not positive 4. If you add 2 plus 4, the answer is not positive 4. So we do not have a solution here using factoring. So we're going to say we are unable to solve using factoring. This method. And the factor method fails here. We have other methods to try later. Another concept to understand is when you hear the word zeros or solutions or x-intercepts, those are synonymous. When you're solving in a quadratic equation, you can call the solutions or zeros. If you turn the equation into a function, you can call these x-intercepts. For example, we did not study functions yet. However, hopefully you have a good idea or at least a small idea about what a function is. But if you write the equation in this form, y or f of x equals x squared minus x minus 6, which is the same, but here it's not an equation. We call it a function in this case because the left-hand side in this case is not equal to 0. So if you graph that equation, if you graph the equation of the function, this is the graph of the equation of the function, the graph of this. If you graph it, then where it intersects with the x-axis is what we call the x-intercepts, which are basically the solutions of the quadratic equation, and it is the zeros of the function. So in other words, if you have a function that is quadratic, in order to find the x-intercepts or the zeros, you're going to set f of x equals to 0, or it's equivalent to y. You're going to set it equal to 0, and you're going to solve it the same way we solved it here. You're going to end up with two solutions. Those two solutions are written as x-intercepts like this. So since we assumed that y is 0, we set f of x is equal to 0, which is equivalent to y. So we said that y is equal to 0, and we found the x's. This is how we find the x-intercepts. Remember, these are ordered pairs x and y. In order to find the y-intercept, which is this point right here, we're going to set x equals to 0 and then solve for y. So if we set x equals to 0 here, we're going to say y, or f of when x is equal to 0 equals 0 squared minus 0 minus 6, which is equal to negative 6. So we have y equals negative 6. We assumed that x is equal to 0. We can write the y-intercept in this format. We can say the y-intercept is x is 0 and y is negative 6, which is we just found. So this is just an idea ahead of time on how to find the x-intercept and the y-intercept, and what are they called when we're dealing with quadratic functions. Another form of factoring is when you have a difference of squares. So if you have a difference of squares, you can still factor, or you can use the square root property. If you factor, the factorization is going to look like this. So as you notice here, the middle term is 0. So you're going to say, I want two numbers. Here is x squared split into x and x. The last term sign is negative, which means I have different signs for the factors. Now I'm going to think about two numbers. Their product is negative 9, and their sum is 0, because the middle term is non-existent. So the b part of the equation is 0. These can be only 3 and negative 3. There is not another option. And then you're going to set these factors equals to 0. You're going to solve. You're going to get x is equal to negative 3. Here's your first solution. X minus 3 equals to 0. Get x equals positive 3, or just 3. So those are the solutions of the equation using the 0 product property to solve difference of squares. If you have differences of squares, you have another option of solving, which is using the square root property. We discussed that in unit number 0, so if you still need to practice the concept, go back and watch the video or the videos. So the square root property happens, or it's useful when we have a difference of squares, because we can basically, when you have x squared minus 9 equals 0, here is a square, here is a square. We know 9 is a complete square or a perfect square. X squared is a perfect square. We can basically add, because the middle term is non-existent, it's not going to cause any trouble, so we're going to add 9 to both sides of the equation. We end up with x squared equals 9. Here is a trick though. Some of you might say, I'm going to take the square root for both sides, but please don't forget that you have to include positive and negative option. The reason why is because both negative 3 and 3, if you square them, you're going to end up with 9. Similar with negative 2 and 2, you're going to end up with 4, and etc. So both of the positive and the negative number squared will yield the same result. That's why when you undo that, you have to include that option. So the right-hand side, the left-hand side will be x equals to positive or negative 3, which is basically means that either x is equal to 3 or x equals, this translates into x equals to 3, x equals negative 3, if you would like to split them. So if you're confused about this sign, this basically just means the two options are a solution. This leads me to the next idea of complex solutions. Sometimes we don't have a difference of two squares. We sometimes have the sum of two squares. How do we deal with that? So if that happens and we would like to use the square root property, we're gonna end up with a problem, slight problem, which is basically we know how to find a positive, the square root for a positive real number. And this is specifically for like square root, not cube root. In a similar way, we can find the square root of any negative number. If you plug that into the calculator, it's going to give you an error. However, mathematicians have came up with a solution for that. And we decided, not me, but mathematicians decided that if the value under the radicand is negative, then the root is said to be imaginary. They gave it the name I, so the imaginary number I, and they defined it as the square root of -1. So I is equal to the square root of -1. So that if you square I, you're gonna square the square root of -1, which will basically the square is gonna cancel the square root, and you're gonna end up with I squared is equal to -1. Now you're gonna ask me, how are we going to benefit from that? Let's assume that you have the square root of -49. We know the square root of 49 as a positive number. However, the square root of -49, if you plug it into the calculator without changing the mode, it is going to give you an error. So how do we fix that? So we know that the square root of -49 can be written as the square root of 49 times -1. And then we know that the radical can be split when it comes to multiplication. So square root of AB is the same as square root of A times square root of B. We know that as a fact. So we're going to split square root of 49 times the square root of -1. We know what the square root of -1 is because mathematicians had defined that. So we're going to say, okay, so I have the 7, square root of 49 is 7, and then square root of -1 is basically I, so the solution is going to be 7I, which means 7 is an imaginary number. The I stands for imaginary. In simple terms, when you have a negative number, let's say you have square root of -36, this is how we do it. Yeah, well, you're going to take the negative out as I, and then solve. So it's going to be I times square root of 36, which is 6. So 6 times 30I. Or let's take it to the other side. Actually, it looks better. So equals. The negative comes out as I out of the radical. So now we have square root of 36 is 6. And then I. Okay. Let's see how we're going to use that property. If we want to solve x squared plus 9, this is not a difference of squares, it's an addition of squares. So if you want to use the square root property to solve this equation, this is how we're going to solve it. We're going to subtract 9 from both sides of the equation. We end up with x squared equals -9. And then we're going to take the square root for both sides of the equation. Don't forget positive, negative here. So the left-hand side will be x equals positive or negative square root of -9. The negative will come out as I, and then the square root of 9 is 3, so the solution is going to be x equals positive or negative 3I. In other words, x equals 3I or x equals -3I. Here is an example. Let's use the method that we learned in order to solve each of these, and we have to be careful. Some of the solutions might be complex numbers. These are complex numbers. Okay, so these solutions are complex numbers. The first one, x squared minus 1. I could use the square root property. I'm going to add 1 to both sides of the equation. We get x squared equals 1. I'm going to take the square root for both sides. Don't forget positive, negative square root of 1. the left-hand side is going to be x equals positive or negative 1. So the solutions are x equals 1 and x equals negative 1. Don't forget, quadratic is second degree, must have two solutions. It could have one, but most of the time it will have two solutions. B. Again, I can use the square root property. I'm going to add 25 to both sides of the equation. We will have 4x squared equals 25. Now, before I take the square root for both sides of the equation, I'm going to divide by 4. So I will have x squared equals 25 over 4. Now I'm going to take the square root. Square root, positive, negative, square root of both numerator and denominator. So the left-hand side is going to be x equals positive or negative. The radical of a quotient can be written like this. So positive and negative square root of 25 over square root of 4. So it happens with multiplication and division. It can split actually. So now I have the square root of 25 is 5 over the square root of 4 is 2. So the solutions are x equals 5 over 2, x equals negative 5 over 2. Number C, 2x squared minus 32 equals 0. Again, I'm going to, using the square root property, I'm going to add 32 to both sides of the equation. So we will have 2x squared equals positive 32. Not 23, 32. Now we're going to divide both sides by 2. So we have x squared equals 16. Now we're going to take the square root, positive, negative, square root. So we will end up with x equals, make a line here, x equals positive and negative 4, which means x is equal to 4, x equals to negative 4. Last but not least, x squared plus 8 equals 0. We're going to use the square root property as instructed. So we're going to subtract 8 from both sides of the equation. We will end up with x squared equals negative 8. Now we're going to take the square root. Don't forget positive and negative square root. We said that the negative comes out as I, and then we can rewrite this as the left-hand side will turn into x equals positive and negative square root of 8i. You can leave it like this, but you can simplify the square root of 8 a little bit. Here, let me do it. So square root of 8 is basically the square root of 4 times 2. And since we can distribute, or you can split the multiplication under the radical into two radicals, we're going to do that. So square root of 4 times square root of 2. We know what square root of 4 is. That is 2. And then square root of 2 remains under the radical. It looks a little bit better, but it doesn't really hurt to keep it in this format. But because I'm assuming you took the prerequisites for this class, you're familiar with radicals. So the solutions are x equals 2 square root of 2i and x equals negative 2 square root 2 of I. Here is a concept that I wanted to include with the concept of quadratic equations, just to link things up a little bit for later. Notice how we had a quadratic equation and a quadratic function. The main difference between the two is in a quadratic equation, it's an equation where you can see an equal sign and you can see one side is equal to 0 or a number. And notice how it can be written of the form ax squared plus bx plus c equals 0, such that a cannot be equal to 0, because if it will be equal to 0, it's no longer quadratic. The first term is going to be canceled and it's no longer quadratic, it's going to be linear. And a, b, c are real numbers. The quadratic function is the function that can be written of the form f of x or y. This side is also known as y. f of x or y equals ax squared plus bx plus c. Notice how this side is not equal to 0. And a cannot be equal to 0 for the similar reason. This a cannot be equal to 0 because if it is, then it's no longer quadratic. And then a, b, c are all real numbers. In your own words, how do you find the x and y intercepts of a quadratic function? So I kind of discussed that in the page number 1, on page number 1, how to find the x-intercepts and the y-intercept. So I'm just going to write it in my own words. So to find the x-intercepts, we set f of x or y equals to 0 and then solve for x, which is going to give you two solutions. And we have been doing that the entire time, solving quadratic equations. We have been finding x-intercepts for quadratic functions, although we're not studying quadratic functions yet. In order to find the y-intercept, we set x equals to 0, and then we solve for y. Okay, and then the solution, we're going to write it is of the form x1, 0, x2, 0. When we find the x-intercepts and we want to find the y-intercepts, the solution is going to look like 0 and the y value that we find. Here is a question for you to think about. Are the zeros of a quadratic always the x-intercepts? Why or why not? I'm going to give you a hint really quick. Notice how some of the equations are going to yield complex solutions. These complex solutions are called, they have sometimes a part that is real, sometimes a part that is real and a part that is imaginary. Sometimes they have only the imaginary part. These imaginary or complex solutions, you're not going to be able to plot them on xy plane. So if you are going to, for example, plot the equation or graph the equation x squared plus 9 equals to 0, you're not going to see that equation of the function physically, or the graph of the function physically. Let me see, not 0. I meant f of x equals 2, or y equals 2. So if you are to graph the function f of x equals x squared plus 9, you're not going to see a physical contact with the x-axis because the solutions from here, or the x-intercepts, are imaginary. You're going to get two imaginary numbers and you are not going to see them physically on the x-axis intersecting with the x-axis. This graph is not going to physically intersect with the x-axis. So in your own words, you can now explain if the zeros of the quadratic always going to be x-intercepts, or why and or why not.